multiplying binomials in chapter 4.2. So in Pascal's triangle, the first and last numbers in each row are 1, and then every number other than 1 is the sum of the closest two numbers to the row directly above it. So if you look here, all of the outside rows are 1, and then towards the center, notice that if we have 1 plus 1, that equals 2. 1 plus 2 equals 3. And you can see here 2 plus 1 is 3, and then 1 plus 3 is 4, 3 plus 3 is 6, and so forth. And so that's how the Pascal's triangle is built. If you think about on the outside rows, the only one that's touching the one above it is the 1, right? There's nothing here. And then same thing here. It's only 0 plus 1, so that makes 1. So every number other than 1 is the sum of the closest two numbers to the row directly above it. The number in Pascal's triangle are the same numbers that are the coefficients of binomial expansion as shown in the first 6 rows. So 0, looking here, that's row 0 because anything to the 0 power is 1. So that applies to the 1. Then we have 1, row 1, that's a plus b to the first power. So it's 1a plus 1b, and then that's 1, 1, and so forth. And this one we know. We have 1a squared plus 2ab plus 1b squared. That's 1, 2, 1. We took a look at this the other day. When we have a cube of a binomial, we have a cubed plus 3a squared b plus 3ab squared plus 1b cubed. Coefficients are 1, 3, 3, 1, just like Pascal's triangle. Now, you'll start to notice a pattern. First of all, the coefficients, yes, they do apply to Pascal's triangle, but we start to notice something about the exponents as well. So let's take a look at the fourth row. You have a to the fourth, and then 4a cubed b, then 6a squared b squared, and then 4ab cubed, and 1b to the fourth. If you think about it, we have the 4, a to the fourth, then the next term is a to the third, then a to the second, a to the first, and the last one is a to the 0. So the a's are decreasing each time. Then you can see that here we don't have a b, so think of that as b to the 0. Then the next term is b1, then b squared, b cubed, and b4. So that's how you can build these, right? You know that with the 3 as well. 3, 2, 1, 0, and so forth. Another thing to note about this as well is that in each term, the exponents should equal to that row. So this is 4. This is 3 plus 1 is 4. 2 plus 2 is 4, 1 plus 3 is 4, and so forth. And you can see that here at the bottom that continues. Okay, so really it's just a matter of recognizing the pattern and understanding how the pattern works, and that way you'll be able to use it. Now let's go ahead and apply this. So you can always build the triangle first of all, and then if you understand the pattern, right? If you know you're going to the 5th row, count this as 0, 1, 2, 3, 4, 5, then you know your coefficients are 1, 5, 10, 10, 4, 1. So let's do this first one, to z plus 3 to the 4th power. Now let's take a look at the pattern, 1, 4, 6, 4, 1. So we know we're going to do 1, 4, 6, 6, 4, 1. And we're looking at the 4th row. So the pattern is a to the 4th plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the 4th. And looking at these again, they should add up to 4. 4, this is 3 plus 1, 2 plus 2, 1 plus 3, and 4. Now we're just going to plug in the values. We have a and b. So this is z to the 4th plus 4 times z cubed times b, which is 3, plus 6 times z squared times 3 squared, plus 4 times z times 3 to the 3rd plus 3 to the 4th power. So this is the bare minimum that you need to show, right? Just plugging in the values. Now we simplify. So we have z to the 4th plus, we have 4 times 3, which is 12z cubed, plus 3 times 3 is 9, 9 times 6 is 54z squared. Then we have 27, 3 cubed is 27 times 4, 27 times 4, which is a positive 108z, plus 3 to the 4th, that is 81. All right, so that's that example. Now in this other example, we do the same thing. Now we're looking at 1, 5, 10, 10, 5, 1 as our coefficients. And we're in the 5th row, so we're looking at substituting a to the 5th plus 5a 4th b plus 10a cubed b squared plus 10a squared b cubed plus 5ab to the 4th plus b to the 5th. So we have our a and our b, and we substitute it in. So this is going to be 2t to the 5th plus 5 times 2t to the 4th times negative 1 plus 10 times 2t cubed times negative 1 squared plus 10 times 2t squared times negative 1 plus 5 times 2t times negative 1 to the 4th plus negative 1 to the 5th power. So now we just simplify. And so this simplifies to 2t to the 5th is 32t to the 5th plus 2 to the 4th is 16. 16 times 5 is 80. And actually this is going to be a negative 1. Negative because we have the negative 1 here. Negative 80t to the 4th plus 2 cubed, that's 8. 8 times 10 is 80t cubed, and the negative 1 just becomes a positive 1. This one will be a negative because negative 1's by itself. So 2 squared is 4. 4 times 10 is 40t squared. Then we have 5 times 2 plus 10t, and the last one is minus 1.